Okay. So let's examine a different series. Okay, so just adding up odd numbers instead of all of the numbers. Okay, so what would this thing look like? Okay, so let's examine just some finite sums of this and see if we can't figure out what this thing actually adds up to if we just added up odd numbers. Okay. Well, if we just plug 0 into that. Everybody, second to write that down. Okay, now when dealing with finite math, a lot of times what you're really doing inside of these problems is you're trying to see patterns. Okay, so what are the patterns that I'm seeing inside of this one right now? Well, let's go one step further. Okay, so we did P of 0, P of 1, P of 2, and then we can say P of 3, which would equal the sum, now K, which equals 0 to 3 of 2K plus 1 would equal now 1 plus 3 plus 5 plus 7 would then come out to be 16. Now, it's really important when you're doing this you can write out a few steps and be very careful with the indices. So sometimes when this problem is derived, if you see it in another place, it'll begin the indices at k, which equals 1, and it'll be the sum of 2k minus 1. So you really, really have to be careful when talking about, well, what is the indices at the bottom versus where does it end at the top, okay? But then, when we look at the right-hand side of this problem, if you want to get the formula absolutely correct, then you need to consider, well, what is going on the right-hand side of this problem? So it's going 1, 4, 9, and 16. Now, when I used to teach this to elementary kids, we would actually go down to the campus beach and we would look at this problem in a slightly different way. Okay? So what is meant by 1, 1 plus 3, 1 plus 3 plus 5, 1 plus 3 plus 5 plus 7? Okay. Let's have a look at this. One, two, three, four. Okay, so we're going 1, 4, 1, 4, 9, 16. Okay, so we have not proved anything at this point. Okay, we're going to do this through induction, but does anybody have a guess on what P of n would actually equal? And I'll draw a similar diagram to the previous problem that we did as well. So just by visualizing the problem, I mean, because what do you do with the method of induction is, well, you have to have an assumption. You have to assume that P of n is true. And then if you can show that P of n implies P of n plus 1, well, then you basically proved the problem. But you need to start with an assumption. Okay? So when drawing a problem like this, does anybody have a guess on what P of n would be?
I would like a general idea of a guess. Kind
Oh.
of, it would be something like, it would be something that would move it over to the next, it's like saying how much it would be. It starts at 0, there's now 2 spaces, so it would be counting up to the next odd. So it would be plus 2, I guess, something like that in my head. That's kind of how I'm connecting it, but I don't really know how to put it, like articulate it.
Okay. Let me put it this way, okay? What is something we can derive from these numbers right here? These are actually the sums. And this is the symbolic representation of the sums. And what can I say? All right, we phrase it this way. Okay, so what did I draw around those boxes? Lines, yes, I drew lines around. Yes. What geometric shape is it? It's a square. What are all the numbers on the right-hand side? They're actually squares. So we have 1, 4, 9, 16. So if you represent these sums of odd numbers, if you just draw this diagram, then you have the concept that, well, what would this number be? It would be something squared, okay? Now you have to be very careful with the notation on this one, whether you're beginning at 0, beginning at 1, if it's 2k plus 1, 2k minus 1. And so from these diagrams, we have that p of 3 is going to equal 16, which is 4 squared. P of 2 would equal 9, which is really 3 squared. P of 1 is 4, which is 2 squared. Okay, so it's always up by 1. Okay, so we can make the assumption, just based upon this diagram right here. Okay, so if we look at P of 3, we'll say, well, P of n would equal n plus 1 squared. Yeah, because when you're at 2, it's 3 squared. When you're at 3, it's 4 squared. So it's always up by 1. Okay, so now from drawing this diagram, we can get to the idea of that P of n equals n plus 1 squared. Okay, great. Now we have to prove this. Okay? So, our proof by induction is going to start out with, okay, you always got to do this first one first. So, we'll start out with P of 0, which will equal the sum k, which equals 0 to 0 of okay. So just that first one right there, 2 times 0 plus 1. Okay, and then we want to verify that this actually equals zero plus 1 squared. Now this might seem kind of trivial, but no, you have to do this first step. Okay? Okay, so just verifying it for the initial position, or P of 0, something. Okay? Okay, now the second step is we are going to assume that P of n, which is going to equal the sum k, which equals 0 to n of 2k plus 1. Run out of room. Is going to equal okay. So we've shown the first step, and we're assuming that the nth step, based upon just our, I don't know how you phrase this, eyeballing it, is going to equal n plus 1 squared. Okay? All right. Now what we're going to do is we're going to investigate P of n plus 1. Okay. So, what would P of n plus 1 be? That's going to be the sum k, which equals 0 to n plus 1. Okay. So now we're just going to have to go one step further. Let's say that this is going to equal the sum k, which equals 0 to n of 2k plus 1. Okay. Now this has to incorporate another term into it, the n plus 1 term. Okay. So plus now 2 n plus 1 plus 1. Okay. So I'm isolating every term before the n plus 1 term. Now, based upon our assumption is that this sum right here, this is our P of n right here, is going to equal n plus 1 squared. Okay. So, here's where we're at right now. And so this would become okay. So now this is just our assumption. Going from this step to this step is just saying, all right, that's our P of n. Okay. Now, what are we going to try to figure out is P of n plus 1 n plus 2 squared? Okay. So we're going to try to simplify this thing and see if it does in fact go to n plus 2 squared. So we have n plus 1 squared plus 2n plus 1 plus 1. Okay. So that would become n squared plus 2n plus 1, right? That's just doing FOIL on n plus 1 squared. And then, okay, so plus 2n plus 2 plus 1. All right, so n squared is going to stay by itself. And then 2n plus 2n would turn into a 4n. And plus 1 plus 2 plus 1, that would turn into a 4. Okay. Which would equal n plus 2 squared. Okay, great. So through induction, we can say, therefore, or the summing of the odd numbers ends up being n plus 1 squared.